that inverse rule with a composition of a function that's inverse does not necessarily always apply when you're dealing with trig functions and its inverse. So in algebra land, you guys talked about last year when you took a function and did a composition with its inverse that you get this cancellation to occur. Like I mentioned, this is not always the case for trig functions. So for example, if I take tangent and do a composition with its inverse tangent, for this composition to work, whatever this value is has to fall in the domain of your inverse tangent. So in other words, this is only true if x is in the domain of the inverse tangent. Now, like I mentioned in the video, if you do the composition always inside out, you don't have to worry about knowing when this rule applies and when it doesn't. All right, so as long as you do the composition inside out, then you're going to be okay. But if you're going to use this rule, this is where I have to caution you. So again, as you talked about inverse composition of itself with a function, again, it can go either way. But again, if you're going to do the composition of the inverse tangent with the tangent of x, for this to work, this value has to fall within the restricted domain for tangent of x. So you've got to look at the domain of that inner function for this composition rule to apply. So for example, in the last one, if this angle is not between negative pi over 2 and pi over 2, because that is the restricted domain for tangent, then you can't use this composition rule. You've got to do the inside out. Like I said, if you always do inside out, then you're okay. Remember, another notation when you see this negative 1 exponent is that arctan of x. Arctan and this negative 1 exponent, it's both notations for your inverse. Again, some books will use one over the other, or they may use both. So you just have to understand that it's a different notation. And remember, because it's an inverse, we switched x and y. It means x is equal to the tangent of y. Instead of writing y equals tangent of x, it's x equals tangent of y. Again, the domain, remember, for your inverse tangent is all real numbers, because that's the domain of your inverse tangent. The range, remember, is negative pi over 2 to pi over 2. The good news is inverse sine and inverse tangent are going to exist in the same locations on the unit circle. Quadrant 2 and quadrant 3 are dead to you when you are talking about the inverse sine and inverse tangent. You can only be in quadrants 1 and quadrant 4, and you have to be from negative pi over 2 to positive pi over 2. And again, remember, inverse tangent does not exist in quadrants 2 and 3 because of the restrictions we placed on tangent in order to make the function a one-to-one function. And again, the restrictions on inverse tangent is similar to your inverse sine. So for inverse sine and inverse tangent, you have to be in quadrants 1 and 4 between negative pi over 2 and pi over 2. So when you're looking, location, 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 you always have to know where you are allowed to be located and then look at the negative and positives to decide your exact location. So when you're talking about inverse tangent, if it's inverse tangent of a negative, out of quadrants 1 and 4, because this is negative, you know you have to be in quadrant 4. So now the question you ask yourself when you're doing your inverse is, what angle has a tangent value of, and in this particular case, negative square root 3? You're doing the unit circle backwards. Your output is now the angle. This is where I mentioned to you you're doing the unit circle backwards. So again, because this is negative, you're in quadrant 4. So down here in quadrant 4, you have to find the angle that has a tangent value of negative square root 3. And it's got to be an answer between negative pi over 2 and positive pi over 2. So again, it's going to have to be at negative pi over 3. You can't say 5 pi over 3. I agree 100% with you that the tangent of 5 pi over 3 is negative square root 3 in quadrant 4. I am not going to dispute that. But the inverse does not exist at 5 pi over 3. Because remember what we had to do was we had to force tangent to be 1 to 1. And it's only 1 to 1 from negative pi over 2 to pi over 2. So here's your negative pi over 3. So there's one of your answers. Inverse tangent of negative 1. Again, it's the inverse tangent of a negative. You have to be in quadrant 4. So again, the question you're asking yourself is what angle has a tangent value of negative 1? Again, you have to be down here in quadrant 4 because it's negative. So it's going to be at negative pi over 4. Again, you cannot say 7 pi over 4. All right, the tangent is not 1 to 1 at 7 pi over 4. Inverse tangent of negative square root of 3 over 3. That's going to be at negative pi over 6. And again, you're down there in quadrant 4 because it's negative. So those are the only 3 angle answers you can give me for inverse tangent down there in quadrant 4. Okay? Now let's move on to the inverse tangent of 0. Well, this is your quadrantal. Remember, that's hitting the x-axis. So we call that a quadrantal angle. So that's 0. Tangent is 0 at 0 degrees or 0 radians. Now we're going to move into quadrant 1 because now you're looking at these inverse tangent values that are positive. So the angle that has a tangent value of square root 3 over 3 in quadrant 1 is going to be your pi over 6. So that's your quadrant 1. Arctan of 1 is going to be pi over 4. And again, it's positive, so you're in 1. And then finally, your inverse tangent of square root of 3 is pi over 3. And again, that's at square root of 3. So those are the only angles that exist for us for inverse tangent. So any questions on your inverse tangent? Okay? Again, this was just like, so again, like I mentioned, you've got to study this. Just like you had to put the time in for the unit circle, you've got to know that you're only going to be using these angles for the inverse tangent. Yeah. Mm-hmm. Now, inverse secant and inverse cosecant are nice because inverse sine and inverse cosecant exist in the same quadrants. So if you know where inverse sine is, you know where its reciprocal inverse function would be. Inverse cosine and its reciprocal inverse secant, same thing. Tangent, remember, always has the twists and turns. Unfortunately, inverse tangent and inverse cotangent don't work that way. That's why we got to spend a little bit of time talking about the inverse cotangent. And it's mainly you have those asymptotes and it's undefined at different places. If you remember, when we looked at the graph of cotangent of x, do you remember where the vertical asymptotes were for cotangent? Where's cotangent undefined? Not at negative pi over 2 and pi over 2 like tangent, but where else? 0 and pi. So if you remember when we graphed the parent function for cotangent, we graphed a cycle from 0 to pi. Then we looked at the key points at pi over 4, 1, pi over 2, 0, 3 pi over 4, negative 1. So that's what your graph of cotangent looked like. And again, we could graph more than one cycle. For example, if I went negative pi to 0, it would look something like that. Look like the reflected tangent. So as you can see, the issue you run into is cotangent of x is not 1 to 1. It fails the horizontal line test. So just like we did for tangent, we have to restrict the domain for cotangent of x. And the restriction is going to go from 0 to pi. To force it to be a 1-to-1 function. So remember, for cotangent of x, without the domain restriction, the domain was all real numbers except multiples of pi. So that's the domain of the cotangent that we studied with the parent function. Any multiple of pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, etc., we're going to have vertical asymptotes. The range, just like tangent, was all real numbers. So to force cotangent to be 1 to 1, the domain restriction is going to go from 0 to pi. Remember, domain and ranges switch for functions and its inverse. The domain of inverse cotangent is the same as the range for cotangent of x. The domain for inverse cotangent is all real numbers. The range is the same as your restricted domain going from 0 to pi. So when we look at the graph of inverse cotangent, instead of having vertical asymptotes, what kind of asymptotes are we going to have on the inverse? We're going to have horizontal. So we're going to have a horizontal asymptote at y equals 0 and y equals pi. Again, I've got these key points on cotangent, pi over 4, 1. So I switch the x and the y, so then when x is 1, the y value is going to be pi over 4. I have the point at pi over 2, 0. When I switch the x and the y, it's going to become 0, pi over 2. 3 pi over 4, negative 1, will go to negative 1, 3 pi over 4. So this is the graph of what your inverse cotangent looks like. Okay, so any questions about the graph of inverse cotangent? Yeah.
The last point, is it above the pi over 2?
Yeah, because it's at 3 pi over 4, negative 1. Yeah, thank you. It should be at 3 pi over 4, negative 1. There. Again, just like all the others, be careful of this theorem. For tangent to become a composition with its inverse, it's only true x has to be in the domain of your inverse tangent of x. Again, if you do the composition like I've been saying, inside out, you don't have to worry about this. So that's different than your algebra functions. Again, if you go the other way, your inverse tangent composed with your tangent of x, it's only equal to x. This is cotangent. All right, I'm writing tangent. Wrong cotangent. Sorry. We do your composition of cotangent with a cotangent of x. Just be careful. It doesn't always work. All right? Again, x has to be in the domain of cotangent of x for it to apply. So just like all the others, remember, inverse cotangent, you may also see arc cotangent of x. Means the same thing, it's just the inverse notation. And it means x is equal to cotangent of y when you switch the x and the y. The domain for your inverse cotangent, remember, is all real numbers. The range is going to go from 0 to pi. So you told me when we were reviewing inverse cosine, you told me inverse cosine, what two quadrants are you allowed to be in again for inverse cosine? Inverse cosine, you can be in what two quadrants? 1 and 2. So just like your inverse cosine, inverse cotangent is also going to go from 1 to 2. Quadrants 3 and quadrant 4 are dead to you for your inverse cosine. and inverse cotangent. Just remember the C's. Cosine begins with a C, cotangent begins with a C. So your inverse cosine and inverse cotangents are going to go together. They're going to be in the same location. So inverse cotangent does not exist in quadrants 3 and 4. Because of the restrictions we had to place on cotangent to make it a one-to-one function. The restrictions on inverse cotangent are similar to your inverse cosine of x. Again, so remember, you're only going to be in these two quadrants. It's the only place you're allowed to be for your inverse cotangent, just like the inverse cosine. So again, know your location. It's positive. You're in quadrant 1. Everybody's positive in quadrant 1. All of your inverses are in quadrant 1. So then in quadrant 1, the angle that has a cotangent value of square root of 3, it's in a different place than the tangent because they're reciprocals. This is going to be at pi over 6. Inverse cotangent of 1, it's positive, you're still in quadrant 1. So I'm going to be at pi over 4. Inverse cotangent of square root of 3 over 3, you're still in quadrant 1. That's going to be at pi over 3. Cotangent and tangent are equal to 0 at different angles, remember. We know that tangent is undefined at pi over 2, but that's where cotangent is equal to 0. So the inverse cotangent of 0 is pi over 2. And again, remember, that's a quadrantal. We're going to be up here at pi over 2. Now you're moving into quadrant 2. So when you see these negative values for inverse cotangent, you know you're negative. So at 2 pi over 3, that's where your inverse cotangent is equal to negative square root 3 over 3. Inverse cotangent of negative 1, again, the angle in quadrant 2 that has that cotangent value of negative 1 is 3 pi over 4. And then lastly, your inverse cotangent of negative square root of 3 is your last angle, 5 pi over 6. These are all where you're quadrant 2. So those are the values you have to know for the inverse cotangent. Remember, the C's go together. The inverse cosine and the inverse cotangent are in the exact same location. The tangent, inverse tangent, and inverse sine are going to be in the same locations. Okay? So let's take a look at some examples. So when you're doing these problems, guys, location, location, location. I always think it's fun to do your trig tic-tac-toe. It's going to help some of you. Arctan of 1. What two quadrants can you be in for inverse tangent? 1 and 4. So cross out the two places you're not allowed to be. We're only allowed to be in 1 and 4. Now look at the sign of this. It's positive 1. So what quadrant would we be located in? 1. So then what's the angle in quadrant 1 that has a tangent value of 1? Pi over 4. Look at number 2. Inverse cotangent of negative square root 3. What two quadrants are we allowed to be located for inverse cotangent? 1 and 2. So now it's negative. So which quadrant are we going to have to be located? 2. So we know tangent of pi over 3 is square root of 3. Cotangent's the other, one with the 3's in it. So this is going to have to be at 5 pi over 6. If you know where the tangents are, the cotangents are going to be the other one when it comes to the pi over 6 and the pi over 3 families. Arc cotangent of negative 1. What two quadrants are we allowed to be in? We're allowed to be in what two quadrants? 1 and 2. It's negative, so we have to be in quadrant 2. So what's the angle in quadrant 2 then? It's going to be what? where is cotangent equal to -1 at what angle? 3 pi over 4. Yes, Maddie?
Oh, no, never mind. I think, yeah.
So now let's go down and do some composition examples. Now this is where you're going to be combining unit circles and the inverses. This is the composition where I said if you work it inside out, then you don't have to worry about remembering that composition rule. So cover up what's on the outside, look on the inside. This is a unit circle function. It is not an inverse. It doesn't have the -1 exponent. It doesn't have the word arc in front of it. So if it's a unit circle, remember you're looking in all 4 quadrants. You're opening it up to all 4 quadrants. Now, where is 5 pi over 3 located? What quadrant is 5 pi over 3? It's in quadrant what? 4. So I'm down here. So then at the tangent of 5 pi over 3, that's just what you took a quiz on, is tangent positive or negative down there? In quadrant 4. Negative. So I know it's negative. It's going to be negative square root of 3. So that takes care of what's on the inside. Now look on the outside. Now you're dealing with the inverse. Arctan. So where are you allowed to be for the inverse tangent? Only 2 quadrants. What 2 quadrants are they going to be? 1 and 4. Because it's negative, which quadrant am I located? 1 or 4? 4. So then the angle that has the tangent value of negative square root of 3, remember, is going to be negative pi over 3. Remember, you can't say 5 pi over 3. That's why that composition rule does not apply. That's why the cancellation does not occur. Because in order for that cancellation rule to occur, 5 pi over 3 has to fall within that restricted domain of negative pi over 2 to pi over 2, which it doesn't. That's why I do that composition inside out and you'll be fine. Let's look at number 2. Inverse cotangent of the cotangent 7 pi over 6. So start on the inside. Again, cotangent 7 pi over 6, it's unit circle. So you're looking at all 4 quadrants. Where is 7 pi over 6 located? 7 pi over 6 is located in quadrant what? 3. Is cotangent positive or negative down there in quadrant 3? Positive. So it's going to be positive square root of 3. Now look on the outside. Now you're dealing with an inverse. So again, for the inverse, you're only allowed to be in 2 quadrants. What 2 quadrants are you allowed to be in for inverse cotangent? 1 and 2. Because this is positive, where am I located? 1 or 2? Positive 1, yeah. Quadrant 1, because it's positive. So then the angle there in quadrant 1 is going to be your pi over 6. So if you look at number 3, look on the inside. Now you're dealing with inverse sine. So where are you allowed to be for inverse sine and what 2 quadrants? 1 and 4. Because this is positive, what quadrant am I going to be located? I'm located in quadrant what? 1. So then what angle in quadrant 1 has a sine value of square root of 2 over 2? Pi over 4. So now look on the outside. Tangent of pi over 4. Again, you're dealing with a unit circle. Where is pi over 4 located? Pi over 4 is located in quadrant what? 1. So the tangent of pi over 4 is just equal to 1. Okay? So any questions, guys, on those compositions?